কারো কিছু জয়েন করেছে তার একটু সময় দেখছি। 33 have so far joined. কতজন রয়েছে তোমরা মোট? What is the total number of students in your section?
Sir, I think 73.
70.
Almost. Sir.
33 have joined. Okay, so before I start, let us discuss regarding the possibility of conducting the class in the morning hours. Morning hours means time around 11:30 will suit me better. So maybe 11:30 to 1. This will be my timing. So is it possible for you to join the class during this time, 11:30 to 1, on some other day? And for me, Monday it is Monday, Wednesday, then maybe also Friday, Monday and Wednesday. This will be better. Is it possible for you to join on Monday or Wednesday? তোমরা দেখো ভেবে সবাই বলো, বা কবে সম্ভব হতে পারে তোমাদের পক্ষে এরকম সময়টা? দেখ তোমরা ভাবো। Now it is 4:48, so let me start. And today actually I shall be it will be the introductory class, so maybe some preliminary things only I shall be discussing, and then the next from next class onward the real content will be started. Okay, so can you see the screen?
Yes, sir.
Is the screen visible to you? So let me start recording because it is necessary for a keep a record. So today I shall be closing around 5:30. Okay, and in the meantime, you think over the timing. Let me know. Then in the morning hours, then if I start from 11:30 on some other day, then it will be better. I can continue around for say 1 hour and 30 minutes. That will be better. Okay. So let me go to the content then. So far 40 have joined. Let us see how many join finally. So the subject is power system performance. I hope the other part of this paper has already been started by Professor Tudu. Has it been started already? শুরু হয়েছে?
Yes, sir. Shunita madam is taking the other part.
The madam is taking. Okay, okay. Then basically power system performance 50% will be covered by me and 50% Shunita madam. Now, what is the role of a power system? Power system, you know that this subject has been introduced to you during the second year classes, distribution and all these things were started. Then in the first semester also, you have actually something were taught to you during the uh, uh, sorry, 1 minute, during the first semester also. Okay, I want to stop this video. Okay, so the role of the, so the function of a power system, that is to supply quality power at cheap rate. Okay, so if the power system can supply quality power, then we can say that the performance of the system is good. Okay, so how to measure the performance of a system? So it will supply good quality power at cheap rate, and it has to maintain the security of supply. Hmm. It will maintain the security of supply. So what is the meaning of good quality power? What is the cheap rate power? How this may be obtained, and what is the security? These things let me discuss first. Then we shall enter into the uh, how these things may be maintained. Okay. Quality of power basically is measured by voltage, frequency, waveform distortion, and continuity of supply. Voltage means actually you have to maintain the declared voltage. Whatever is the declared voltage, at whatever may be the level, at the distribution level, at the transmission level, at the generation level, you must maintain the declared voltage. Obviously, there is a specified tolerance of voltage. Okay, according to electricity rule, some small deviation in the voltage is permissible. That may be done. Okay, and frequency also has to be maintained at the declared value. And then obviously voltage are different, and different part of the power system, and the generation and the transmission and the distribution voltage levels are different. But whatever may be the voltage level, declared voltage level, that has to be maintained, and a small variation is allowed in there. But the frequency is common in our system. The frequency is common in our system. That is not appreciable. But later on, what happened, at the distribution level, different types of loads are being introduced, particularly during the last few decades, where power electronics controlled loads are introduced, and these power electronics controlled loads are responsible for the introduction of distortion in the current, and the distortion in the current will finally results in the distortion in the available voltage waveform. So this distortion has to be maintained within an acceptable limit. This is the condition now. Previously, there was almost no distortion when nonlinear load or this power electronics driven loads were not present. Previously, they are not present in the system, but during the last 2-3 decades, they are coming in great number, and as a result of that, at the distribution level particularly, there are distortion in the current wave, and there are distortion in the voltage wave. So these distortion are to be kept within acceptable limit. How to keep this distortion within limit? Then you have to actually avoid distortion. You have to compensate for this distortion. These distortions are created by different types of load. So loads are to be compensated. Loads are to be assisted by some other devices, such that the resulting distortion introduced in the system waveform, is within acceptable limit. Okay? And continuity of supply, basically whenever the consumers are demanding power, consumer switch is made on, the supply must be available. This is the continuity you can say. But obviously this cannot happen always. Sometimes there will be failure, but the supply utility should try to maintain the power at the maximum time they can. Okay, if they must maintain the power, the consumer should get the power whenever they demand it. So the continuity of supply, obviously this is a part of maintenance, this is a part of design of the system. So those things are to be taken care of in a different way. Waveform distortion is not within our purview, or particularly in this semester, so we shall avoid that also. What we shall discuss in this paper is basically regarding the voltage and frequency, how they may be kept within the acceptable limit. Voltage will vary, but how you can control the variation of voltage, limit the variation of voltage, compensate for the variation of voltage. And frequency also will vary, how the variation of frequency can be limited to a very small permit that specified limit, how that can be kept within the specified limit, and how voltage can be controlled, how frequency can be controlled. These things will be discussed. Okay. Then cheap rate, another uh, you can say that the role of power system is to supply at cheap rate. How to supply at cheap rate? For that, obviously, we to design the power system at the optimum way, in the optimum way. Then generation has to be economic, and operation also has to be economic. So there are various aspects of system operation. Those will be discussed in other papers. Economic generation will be discussed in this paper, but will be taught by Madam. With Madam Sunita, Madam will discuss this thing in the other half of this paper. And optimum design, obviously, design of power system, design of system components partly were done during the last semester. So the conductor, how to design the conductor, okay, all these things. And gradually in different papers, we will have some idea regarding these things. And system security means ability of the system to withstand unplanned disturbances. Disturbances cannot be planned. When a fault will occur, because you know that more than 90% of the power systems are exposed to open air. Okay, you can see that there are overhead transmission lines. Overhead transmission lines are insulated from tower only. They are hanging from the tower through porcelain insulator. So insulation lies there only. But between two conductors, air is the only insulator. Okay, so more than 90%, or even you can say the more than 98% of the system is exposed to open conductor, open air. As a result, there may be fault, occurrence of fault at any time on the system. So fault may occur anywhere. Fault may occur on transmission line. Fault may occur on a transformer. Maybe a generator is faulted. So when a generator is faulted, or transformer is faulted, or transmission line is faulted, or even a bus bar is faulted, the affected part must be disconnected from the rest of the system as soon as possible. And who will disconnect this affected part? That means the faulty part. Obviously, there are circuit breakers, there are relays. Who will disconnect the affected part of the system? So relay will uh, identify that there is a fault on the system, and circuit breaker will immediately disconnect the faulty part, because the circuit breaker basically is a switch. So there will be circuit breakers, and they will disconnect that faulty component from the healthy part of the the power system, because otherwise the total system will be affected. So the power system must have the ability to withstand the impact of this fault. Why we talk about the impact of fault? Because a generator is delivering, say, hundreds of megawatt of power to the system. So when a generator is faulted, it will no longer be supplying power to the system. So there is a loss of generation, you can say. Then some other generator must be available in the system to supply the power that was being supplied by the faulty generator. So similarly, if a transmission line is disconnected from the system, this transmission line was say, carrying, let's say, some 200 or 300 megawatt of power. So there must be some other path available, some other transmission lines available to carry that power. Okay, so these are the requirements. So system security, and there are other issues related to disconnection of generator, disconnection of transformer, basically the stability of the system, and this stability will be discussed in this paper. I shall be discussing this. Okay, so system security has to be maintained, quality of supply has to be maintained, power must be supplied at cheap rate, and when we talk about the quality of power and performance of the system, we measure it through the quality of voltage, through the quality of frequency, quality of the waveform lines. Okay, so now let us see uh, why it is necessary that frequency and voltage of the system are to be kept constant. So gradually we have given you an idea regarding the role of a power system, what it should cover, what it should do. Now we are entering in the topic of our subject now. Okay, so we shall be mainly discussing here in this paper regarding the voltage and frequency, how voltage and frequency are to be kept constant, and also we shall be discussing regarding the stability of the system. Hmm. Stability is related to the synchronous operation of the power system. So gradually I shall be discussing all these things. So now the question is why it is necessary that the frequency has to be kept constant. Okay. So now you see that I think you can see this screen also where the PPT is this page is shown. Speed of consumer plans changes with supply frequency. Production process gets hampered. This is one of the reason. Other reason is I shall be explaining this. Synchronous operation of generators. This is the other reason, and active power consumption of a load depends upon supply frequency. So these are the 3 points which are which I shall be discussing here, and these are the reasons why frequency has to be controlled. Frequency has to be kept constant. Now the question is, do you know why while we are talking about the speed of consumer plants, means we are talking about the uh, production process, you can say, or some industrial process where basically there will be mostly motor loads running. And motor loads mean AC motor loads. Okay. AC motor load means obviously there will be induction motor. What happens to the speed of the induction motor when the supply frequency varies? Can anybody answer this question? What happens to the speed of the induction motor when the supply frequency varies? বলো কেউ বলতে পারবে কি হবে
Sir,
সাপ্লাই
speed,
ফ্রিকোয়েন্সি ভ্যারি?
sir, synchronous speed is dependent upon the frequency, and
হুম,
so synchronous speed is proportional to frequency. Uh,
ফ্রিকোয়েন্সি, হ্যাঁ, দেন what happened? Therefore, if
so
the
frequency decrease.
supply frequency varies, then obviously the speed of the motor also will vary. Okay, and
Yes,
if the speed of the motor varies, then what will happen? Obviously, the speed of the production process also vary. Then quality of the product also will vary. That means it is therefore very much necessary that the speed of the production process, that means motors of the production process, should maintain the desired speed. And since the motors are of mostly induction motors, therefore supply frequency also has to be maintained constant as far as possible, because otherwise the production process will be hampered. Okay, so this is one of the reasons, because if the supply frequency varies, if the supply frequency increases, then speed of the motor will increase, because uh, that that speed of the induction motor depends upon supply frequency. That means synchronous speed also varies along with that. Synchronous speed also varies with that. Similarly, when the speed decreases, frequency decreases, speed also decreases. Okay, this is one reason. So quality of production process is one of the reasons why the frequency has to be kept constant. The second reason is synchronous operation of generators. So you know that most of the generators in power system till today, still today are synchronous generators. In any power system, you can say, if we talk about Indian system or system anywhere, you can say that 80%, around 80% of the generators are synchronous generators. That means remaining 20% of the generation that is of power that is basically coming from renewables. Renewables are having induction generators and PV cell basically, solar PV. Okay. So that except those two, that means around 20%, excluding solar and wind generation, remaining around 80% is from synchronous generators. And synchronous generators, if they are to be run at uh, in parallel condition, then their frequency must be same. Okay, and we can say that all the generators in a power system are effectively connected in parallel. There are hundreds of power stations located at different part of the system. If you talk about Indian power system, its capacity is around 370 gigawatt. 370 gigawatt. So obviously 370 gigawatt, obviously where from this power is coming? This is coming from mostly from synchronous generators, and they are located at various part of the country. They are distributed at different parts of the country. So they are geographically distributed, but electrically they are effectively in parallel. So parallel operation of the synchronous generators require that the frequency must be kept constant, because if the frequency of one generator changes, then it will impact the frequency of other generator. It will impact the frequency of the system. As a result, parallel operation of the generators will become impossible. And maintaining this synchronism is maintaining the stability. Stability we shall be discussing later on, but the part of stability that we shall be discussing in this semester is maintaining related to the maintenance of synchronism between the synchronous generators. Okay, this is another reason why the frequency has to be controlled, frequency has to be kept constant. Then the third reason is active power consumption of a load depends upon supply frequency. Hmm. How much active power a load will consume, that depends upon supply frequency. For example, you consider again a motor load. Say we have a motor load, say induction motor load, that is say connected to a conveyor belt. Say that conveyor belt, there is load kept on the conveyor belt, and the motor is actually transporting this load from one place to another. Now assume that the frequency of the system is increased. So what will happen? The speed of the induction motor also will increase, and but the load is constant. So the same load, the motor is now shifting, transmitting at a higher speed. So obviously the power consumption will increase. That means with the increase in the supply frequency, power consumption will increase. Similarly, power consumption by the load will increase. Similarly, with the reduction in the supply frequency, power consumption by the load also will decrease. So if this happens, then it will be very difficult for the supply authority to estimate what is the required power demand of the system at present. Because supply authority or the people who are actually generating power and delivering power, they must have an idea what is the requirement of power at this moment, or what will be the requirement of power say at some time, say 2 hours from now. What is the connected load during this time? These things are more or less known to the supply authority people because they have the data of previous operation, previous day's operation, and the past operation of the system. So they know how much load is generally connected. So accordingly, they plan their operation. So if the supply frequency changes, then it will be difficult for them to plan the operation because actual demand will not be known to them. Okay, so this is the other reason why frequency has to be kept constant. So is there any question? Is there any doubt? Whatever I have discussed so far, particularly regarding the frequency control, why it is necessary, why frequency has to be kept constant. Is there any doubt? Any question from you? কারো কোনো প্রশ্ন আছে এখানে বলো? যদি না থাকে, next let us see why voltage control is necessary. So we have talked about the frequency control, why it is necessary. Now let us see why voltage control also is necessary. All apparatus are designed to operate at declared voltage. Whatever apparatus will be designing or you will be purchasing even say, it is designed and manufactured for a specified voltage, for a declared voltage. So if the voltage varies, if the voltage is outside that voltage, declared voltage or design voltage, then what will happen? Then efficiency and safety of the equipment will be hampered because the equipment will be efficiency of the equipment will be based at the declared frequency. Similarly, life expectancy of the equipment also will be hampered. Why? Because if the voltage is greater than the declared voltage, greater than the design voltage, then there will be overstress on the insulation. As a result, the life of the equipment will be hampered. If the voltage is below the frequency, then obviously it will not be stress, but efficiency will be hampered. So at the declared voltage, the efficiency will be based and the expected life of the equipment also will be also can be maintained. So these are this is one of the reasons why voltage has to be kept constant. Another reason is again that is related to the stability of the load. What happens to motor load? You know that most of the loads in any power systems are basically motor loads. And motor loads are known as constant power type of load. Constant power type of load means if the voltage varies, then motor loads will try to maintain constant power. Say voltage is decreasing, so what will happen? The motor load will try to maintain constant power by drawing more current. Okay, so at reduced voltage, it is drawing more current. So this more current will cause greater voltage drop in the system. Right? Greater voltage drop, where the voltage will be dropped? Obviously, starting from the generator to the consumer end, there are different components like generators, because the current is more in the generator, voltage drop will be more. In the transformer, voltage drop will be more. In the transmission line, again the voltage drop will be more. Again, coming to the load end, there will be distribution transformer. There also is having is some impedance of the transformer. Then there will be greater voltage drop. As a result, because of increased current drawn by the rotor, current drawn by the motor, there will be increased voltage drop. So already the voltage was less than the normal. Now, because of the reduced voltage, because of the increased voltage drop, voltage at the consumer end will decrease further. At the reduced voltage, again there will be increasing the load current because the motor load will try to maintain constant voltage. So it will again draw more current. At the increased current, again the voltage drop, again there will be more voltage drop. So if this process continues, then what will happen? Voltage will go on decreasing, and a point will come when the voltage of the load node, voltage at the terminal of the node will collapse. Okay, the situation is very similar to the issue that perhaps you have seen. You can remember the characteristics of DC shunt generators. If you increase the load, terminal voltage decreases. If you go on increasing the load again, then what happens? A point comes when there is suddenly a collapse of voltage. Voltage goes from the low value to zero gradually. Okay, it becomes zero gradually. So this thing happens. So similar will be the situation in power system. With this type of situation, when because of the increased current drawn by the load, there is a collapse of the node voltage. This situation is called the voltage collapse, or this is a problem of voltage stability problem. So this type of problem will occur if the system voltage is not maintained properly, system voltage is not controlled properly. That means whenever there is a reduction in voltage, the attempt of the power system people has to be to control the voltage, to improve the voltage by some means such that voltage is kept within the acceptable tolerance limit of the declared voltage. Okay, so these are the two reasons why system voltage has to be controlled. Now, any question here, any doubt here? Why voltage has to be kept constant? Why voltage control is necessary, and why frequency control is necessary? Is there any question? Is there any doubt? বলো, কারো কোনো প্রশ্ন আছে?
মোটর
If
লোড
there
মানে
is
কি
no,
কি বলেছিলেন যে পাওয়ার কনস্ট্যান্ট থাকে?
motor load mostly are constant power type load. Constant power type load characteristics কিরকম হয় যে they are also designed for a specified voltage, all right, but if the voltage deviate from the normal, then they will maintain constant power. এবার constant power maintain করতে গেলে তাকে কি করতে হবে? তখন লো ভোল্টেজ কমে গেলে একটু বেশি কারেন্ট নেবে। এবার বেশি কারেন্ট যদি নেয় তাহলে তার জন্য বেশি ভোল্টেজ ড্রপ হবে। বেশি ভোল্টেজ ড্রপ হওয়া মানে যতটা ভোল্টেজ ছিল তার থেকে আরেকটু ভোল্টেজ কমে যাবে। আমরা ধরে নিচ্ছি যে at the generator terminal voltage is kept constant. Generally this is done. Generator আমরা পরে দেখব যে যতক্ষণ পারে, if it is within their capability, they try to maintain constant voltage at their terminal. সেই জন্য আমরা ধরে নিচ্ছি জেনারেটর এন্ডে ভোল্টেজটা কনস্ট্যান্ট রয়েছে, কিন্তু এইবার লোড এন্ডে অলরেডি কম ভোল্টেজ ছিল, বেশি ভোল্টেজ ড্রপ হওয়ার জন্য কি হবে, ভোল্টেজটা আরেকটু কমবে, তখন আরেকটু বেশি কারেন্ট নেবে। এরকম একটা ক্যাসকেডিং এফেক্ট হতে হতে একটা সময় এরকম হতে পারে যে দ্য ভোল্টেজ উইল কোলাপস অ্যাট দ্য লোড এন্ড। অর্থাৎ কোলাপস হওয়া মানে ওই ভোল্টেজটা ওইখান থেকে সাডেনলি ক্রমশ জিরোতে চলে গেল। এবার একটা লোড একটা নোডের ভোল্টেজ যখন জিরো হচ্ছে, then this part of the network is connected to the other part to lines, maybe distribution lines and other lines, তারও ভোল্টেজটা ফোল করবে। এইভাবে টোটাল সিস্টেমের ভোল্টেজ collapse করতে পারে। and this problem is called the problem of voltage stability. অর্থাৎ ভোল্টেজ যদি তুমি কন্ট্রোল করতে না পারো, কন্ট্রোল না করো, তাহলে সিস্টেম ভোল্টেজ স্টেবিলিটি will not be possible to maintain. কাজেই এর জন্য ভোল্টেজটাকে উইদিন দ্য পারমিসিবল লিমিট অফ ভেরিয়েশন কনস্ট্যান্ট রাখতে হবে, ডিক্লেয়ার্ড ভোল্টেজের কাছাকাছি যতটা সম্ভব মেনটেন করতে হবে। অলরাইট,
Yes.
ক্লিয়ার? And now, why frequency changes? The next question is therefore now, why the frequency changes? Okay. The reason for voltage frequency change is the unbalance between the active power generation and the active power demand. I shall discuss this issue and we stop today. Okay. Say, to discuss this point, let's take a situation where this is shown in this figure. Say we have a generator and there are two loads. One of the loads is connected, Z1, it is connected to the system, and Z2, this switch is open here. So, so now assume that this load is carrying a current, drawing a current of I1, and as a result, the output torque of the generator is say T1. So what is the input torque? Say this is T in is the input torque. So if we assume that the generator is operating at steady state, that means it is maintaining its declared speed, then or synchronous speed, then obviously T input and T1 they are equal because there is no unbalance between the input and output torque. Because any unbalance between the input and output torque will result in the variation of speed of the generator. Since the generator is maintaining constant speed, obviously T input and T output they are equal. T output here is T1. We are assuming that there is no loss inside the generator. Okay, so let us assume that it is lossless. This is a simplifying assumption. There will be small loss, but for the time being, we can ignore that loss. So obviously there is then input power and output power, they are same. Okay, what is the input power? Input power comes from the turbine, okay, enters into the generator. So it is coming from the prime mover, and output is the electrical power. So now say that second load J2 is switched on. As soon as J2 is switched on, what will happen? It will also draw current. Say it is drawing current I2. Okay. So what will be the total current now in this situation? Total current will be I1 plus I2. So I1 plus I2 is the total current. That means output torque will increase because previously it was due to I1. Now it is I1 plus I2. So output current increases. But what happens to the that means that output torque increases. But what happens to the input torque? Can it increase with the increase in the output torque at the same time? Can it increase immediately?
No, sir.
Why it cannot increase?
So that is a mechanical system, and mechanical quantity cannot change instantaneously.
Cannot change instantly, and for changing the input, obviously some actions are to be taken. Those
Yes, sir.
actions are to be sensed first. So so therefore what will happen? If the input remains fixed, input torque remains constant, but output torque increases, so there will be a deceleration of the generator. Then the speed will decrease. Okay, generator speed decreases means frequency of generation will decrease. So when the load increases, the immediate effect is that there is a reduction in the frequency. Now, because there is a reduction in the speed of the generator, because input is smaller, input is less, output is more. Now, you see that uh, frequency decreases because output power increases. But what happens to the input power? It remains same. Okay, input torque remains same means input power also remains same. Output torque increases, output power also increases, but input power remains same. That means there is a difference between the input power to the generator and output power from the generator. Generator delivers more power than it receives from the prime mover. So from somewhere it is delivering this power. Obviously, from somewhere it has some stored energy and in the form of kinetic energy, from where it is delivering this power. So at the cost of reduction in speed. So what is the basic reason for the variation in frequency? Therefore, obviously it is the unbalance between the input power and output. That means you can say that speed varies, speed varies or frequency varies because of the unbalance between the input and output power of the generator. Is it clear? Is this point? Is it clear? Why frequency varies? Why frequency
Yes,
will
sir.
vary? That means load will be changing in a system. Never the load is constant. Every moment there is some switch on, there is some switch off action by the switching of action by the consumers. So as a result, sometimes there will be in reduction in demand, sometimes there will be increase in the demand. That means there will be variation in demand, and with the variation in demand, there will be variation in power between the input of the generator and output of the generator. As a result, there will be variation in the frequency. So our role is to see how the generator can maintain the frequency constant. That means when the power demand increases, you have to arrange for the increased power output. That means the input power to the generator has to be increased. When the power demand decreases, you have to arrange for the reduction of input power to the generator. This thing has to be done. How this thing will be done, we shall see later on. Okay. And before we do that, we shall see why the voltage changes. So this part I shall be discussing in our next class, because I shall have to close at 5:30 today. I shall see how who are now present, and then I shall close. So what you do, uh, you discuss among yourself, and in the WhatsApp group also you may inform me or you may call me and let me know if it is possible to arrange the class on some other day. It need not be Friday. It may be Friday also, no problem. In the morning hours from 11:30 to 1, if this time suits you, and on which day it suits you. So that will help me, so that I shall be in a position to continue the class for longer time. Longer time means 1 hour and 30 minutes, around that. Maybe sometime, somewhat less time also. No problem. Okay, so you discuss among yourself and let me know later on. All right. So now let me see who are present today. But the attendance is really poor. Around 50% are present only. Abhijit Dash, Abhijit Dash, Abu Soyed Sheikh,
Yes, sir.
okay, Ogniv
Yes, sir.
Chatterjee,
Yes, sir.
Akash Singh Rai, Akash
Yes,
Singh
sir.
Rai,
Yes, sir.
Amisha Parvin,
Sir.
okay, Ananda Chakraborty,
Present, sir.
Anubhav Rai,
Yes, sir.
Anushree Majumdar,
Present, sir.
অরিত্র মজুমদার, দুজন অরিত্র মজুমদার, আমার হচ্ছে একজনই হবে। অরিত্র মজুমদার দুজন দেখাচ্ছে, যাই হোক। অর্কপ্রভ হালদার,
Present, sir.
দেন অর্কপ্রভ নন্দী,
Present, sir.
বিপ্র দাস,
Present, sir.
বিশাল বর্মন,
Yes, sir.
গোপাল মেদ্দা,
Yes, sir.
হিমাদ্রি দাস, ঋষভ মহাজন, জসিমউদ্দিন মন্ডল,
Yes, sir.
জয়ত দত্ত,
Present, sir.
জ্যোতিরিন্দ্র সোরেন,
Yes, sir.
জ্যোতিরিন্দ্র সোরেন, নয়ন সারেন,
Yes, sir.
ঐন্দ্রিলা হালদার,
Yes, sir.
পৌলমী দাস,
Yes, sir.
পুষ্পল তরফদার,
Present, sir.
রাজর্ষি ভট্টাচার্য,
Yes, sir.
রুকসন্দা হোসেন,
Present, sir.
সৈকত দাস,
Present, sir.
সম্বিত বিশ্বাস,
Present, sir.
শাশ্বত মুখার্জি,
Present, sir.
সৌভিক নাগ,
Present, sir.
সুব্রত দালাল,
Present, sir.
সুস্মিত রুদ্র, স্বর্ণদীপ সাহা,
Present, sir.
স্বস্তিক কাঞ্জিলাল।
Present, sir.
ওকে,
Sir, বলছি অভিজিৎ দাস is present.
অভিজিৎ দাস প্রেজেন্ট। ওকে,
Yes, sir.
anybody else?
Sir, Mosmi Soren present.
Mosumi student present. Okay, anybody who could
Yes,
not
sir.
respond earlier? আর তাহলে তোমরা আমাকে পরে জানাবে, তাই তো? ডিসকাস করো এবং জানাও যে whether it is possible to arrange